graphic key is embedded in your TOR binary. So you know that that is the consensus that I signed. Because if you trust the TOR binary in the first place, if you trust that I am who I say I am, then you have a good copy of the TOR network from me. And what you do is you make sure that these servers all agree. That's the idea of the consensus. So if, for example, you have a bad routing connection, like you can't make a connection to a particular server, and maybe only one directory authority can connect to it, then probably, in that case, it won't be part of the network consensus, because it's not really universally reachable. And this is a clique topology, where all the servers can talk to each other, and all the directory authorities can connect to all the servers. So that has some scaling problems, which are evident when you try to have like 10 million nodes. You can't have 10 million nodes all talking to each other at once, probably. Maybe if you're really good, but I doubt it. But basically, this centralized directory protocol is a compromise. We could just have one directory protocol server, just one. But we thought that was a bad idea because then you can coerce a directory authority operator, right? You can try to coerce me. Here I am in Jordan, right? You can, I don't know, take me out to dinner, right? But probably I'm not going to do something bad to the network. But even if you could convince me that it was in my own best interest, you won't convince the other 6 people that are geographically distributed around the world. So this is a really important trust dynamic that operates based on some social realities. Like one of the guys that runs one of the directory authorities, he's a Debian developer and he lives in Austria and he never leaves his town, basically. So unless you're going to drive to Austria and kidnap him, he's probably not going to change his mind. He's a pretty stubborn guy. We love him. But he's a little stubborn, so he's not going to bend to, say, the government of the United States. If the USA says to him, you have to do something, he's going to say, no, I'm an Austrian citizen, you have no authority to tell me that, go away. Right? And so that keeps you safe. And we'd like to meet people in the Middle East that would be like basically able to run something like this, because we think a diverse set of interests will in fact cause the network to be even more secure. And I mean, if you know people that are interested in this, that have some bandwidth capacity for it, it's something that we can talk about. And we'd like people like that to join our community, because we think that people that are in this community can help the rest of the world to interface with the TOR network in a good way that's trustworthy. And we think it's important that you don't just trust us because we say to, but because people that are in your community use it, they vet it, they read the source code, they read the protocol, and they maybe in the future really run one of these trusted directory authorities, so they know that it's not just us saying this. Because whenever someone is making this promise that you should trust them, you really have to ask, like, who gains from this? Who benefits? Usually when it's a commercial company, the CEO of the company, the workers at the company, they benefit. And there's a guy, his name is Matt Blaze. He's a brilliant security researcher. And he said once about certificate authorities that certificate authorities only keep you secure from people whose money they are unwilling to take. They're in a business, and their business is keeping you secure. And as soon as someone presents a business opportunity that is more valuable, like you're allowed to keep running your business. Well, obviously, making that compromise is something that a company will often have to do. So it's extremely important that we don't, as the TOR network, as operators in the TOR network, we don't end up in that situation. That's why the TOR project, the nonprofit that writes the software, and the volunteers that are a part of it, we don't actually run the network. Like, I came to work on TOR by running like 10 or 15 TOR servers around the world. And they're like, wow, you really like this anonymity thing. Do you want to help like write some software? And it's like a Tom Sawyer and Huckleberry Finn story. Painting this fence sure is fun. Don't you want to paint the fence too? And I got suckered in and I started painting the fence. And I hope that some of you too would like to paint this fence. Right? We have some problems, right? What we have seen in Iran and what we have seen in China is at least 2 blocking events that I can think of off the top of my head, but we may be on the verge of seeing more blocking events. The trusted directory authorities, they have a list of all the TOR servers, right? What's wrong with that picture if you want to stop people from accessing the network? Anybody? You? Yeah.
You can get these servers and block them.
Sure. So let's paint a picture here. You have a country. It has a monopoly on internet access granted to, say, a telecom. Does that sound familiar? Yeah, it does? Oh, who could have guessed that? Okay, let's say that somehow through the ITU or whatever, this telecom company has a good centralization of their infrastructure because they think centralization is the way. They download that list from the directory authorities every hour, and they put it in the state firewall, and that's it. You cannot connect to the anonymity network anymore. Sound familiar? You ever try to access a website and it was blocked? Yeah? Can someone here name a website in Jordan that's blocked? Ah, so it's like a spider web. In China, it's also like a spider web. Some universities, they have filtering systems, and some ISPs, they have filtering systems. And sometimes you have universities that get access from the ISPs that have filtering systems, and then upstream from that, the government does filtering. So you have like all of these different people that are trying to censor you, right? And you have to like weave your packets through them, right? And you have to get past them. And the problem is that when you then have a network where that is possible, you end up in a situation where they just block it, right? Then you can download the full list and you're totally in trouble. Oops. Right. So what we've done is we say, for people in China, I have a good friend, he lives in China, and he's there to learn Cantonese and to learn Mandarin, and he's a really smart IT guy. And he helps people in China to use TOR, and one of the ways that he helps them is that he has a server outside of the country. I actually pay for it and run it. It's my own personal server. And when I go to China, I use it as well. And anybody that's in China right now, or anybody that's in Iran right now, they're this blocked user, right? So if they tried directly connecting to Relay 1, they would get, in China, a bidirectional TCP reset, right? The firewall would say, no, Relay 1, reset that TCP connection. And block user resets it. So on both sides, the system has been tampered with and the TCP connection has been torn down. In some other types of firewalls, you have more advanced and less advanced stuff. In Iran, some places they just drop the packets entirely. Like you send a packet to the Tor server and it never goes through. So they don't need to tear down the connection because they simply there is no connection. It didn't happen, right? They just erase it like they do with a lot of things. And this happens a lot of places. Like when I was in Canada, I was talking about China's filtering, and I was giving a talk at, I think, a TELUS conference center in Vancouver. This is supposed to be like, one of the most free countries in the world, and certainly in the West. And that's such a load of hooey, Because what happened is I said to everyone in the audience, so go to our website, torproject.org. And a bunch of people open their laptops, and they try to go, and they're all blocked. Right? Because the TELUS conference center thinks that it's acceptable. I think it's TELUS, but I could be wrong. But the conference center there, they just decided that that would be bad. They didn't want people looking at bad ideas on the internet. So they, of course, try to block access to everything that allows people to obviously access that information in a consensual way. Right? It's one thing to say you want to stop children from accessing bad content. I understand that argument. I think it's stupid. I think that it's a flawed argument, but I understand where they're coming from. But to intentionally block access to tools to get around that type of filtering means that someone understands what they're doing. They understand they're trying to reach some information that is somehow not allowed to be seen or to be heard or to be read. And they're trying to reach it. And so for companies to then block that, it's indefensible, I think. So that said, it happens. So what the solution is that Alice is a friend of someone outside of the country, and she runs a private Tor server. But we call it a bridge, because it bridges between the known Tor network and the internet that is being filtered. So it's this unknown section. It's an IP address that just allows a connection. So it's a lot like running a proxy, just a normal proxy. But you don't have to trust Alice in the same way you do a proxy, because it's just the first server in the 3-circuit hop. So what that means is that Alice knows that it's you, but Alice doesn't know where you're going, and Alice doesn't know what you were doing. So you still get a lot of the same properties that you would want, but basically it means that Alice is effectively helping you to circumvent that firewall and to circumvent that filtering. Tor tries to look like Firefox and Apache with SSL. So just trying to do protocol filtering,